Afternoon, antenna fans. Paper editing is on hold while I work on finishing the experiment on the quarter wave end-fed antenna with no balun, no UNUNS, no tuning, no tuners, and no clamps. What it is inside those plastic bags, and no, you can't see it. It is very touchy to adjust, extremely touchy. So very touchy, it may not be practical as an antenna. I've done it mostly for proof of the concept. And here is the reading on the MFJ Happy Box. And when I say perfectly matched, I mean so perfectly, it reads R50 and 1 ohm reactive. It doesn't get any better than that. Watch what happens when I just touch the cord that's holding it. If I get close enough and touch the cord, it changes. See how it changed the R value? What that's doing is coupling from my body. Actually, what I'm doing is put my hand around the transmission line. But rather touchy. We're just on the edge of a tremendous blackout. Something about an M flare, I think it is. So I'm not going to even bother trying to put this on the air. There's no point. Nobody can hear me on my really good antennas. They sure ain't going to hear me on this short thing. But this is proof of the point. You don't need balance for antennas. You don't need balance for end feds. All antennas are end fed. This is just a vertical antenna turned horizontally. Vertical antennas just stick a ground rod in the ground to shield the coax. In theory, hook the center conductor to the bottom of the pole and you got a 50 ohm vertical. That's in the old radio handbooks. So there are no baluns here. I don't need them. You don't need them. So as what I predicted, perfect matching. Absolutely perfect. And at about 5'3" off the ground. There it is. There's the ground. So anybody in a wheelchair, somebody that has to use a walker, somebody with limited physical mobility can do this. So proof. After I got the mechanical instabilities out of this thing, got it tightened up, it is perfectly matched. A good part of the point of this is not to make this. This is trivial. The point of doing this is that this is half of the 15-meter dipole over here. Exactly the same wire, same length, same everything. But the point of this is to separate out one wire of that to be able to test its characteristics separate from the dipole. Now the thing I mainly want to know is, how does height affect it? So if I'll reach way over here away from the antenna and the measuring box, and I'll grab the cord, no, it freaked out. This analyzer has a habit of freaking out. It says SLP and goes nuts. Okay, there's 50 and 0. Doesn't get better than that. So I raise the cord. Has anything changed? No, it hasn't. I've raised the feed point a foot. Nothing changed. Now the thing to be answered is, why does changing the height of a dipole feed point make a difference? One for you to think about. Okay, I can't resist, because just what we do. 15 meters, no indicate. Yeah, there's a tiny blip. Let's see how much power that is. 50 watt scale. 20 watts. 20 wattos. A little bit of SWR climbing. There are poor connections at feed point. So that makes a case for only using the extremely low power analyzer to do testing, and realizing that even at that MFJ unit putting out 10 or 50 milliwatts is still going to cause a little bit of that. but 20 watts might be quarter, half an amp, something like that. Quite a bit of current. There are bad connections where the wires from the feed line direction clamp onto the ends of the antenna wire. So anyway, what is there to hear? Not squat. Hear the static. There's a huge monstrous blackout going on. Not even anything on 076. Let's try 20. So it is picking something up. It's going to be badly mismatched. Yep, high SWR. Let's try 17. Bad mismatch. Up here to 890. 12, badly mismatched. 10, badly mismatched. So at 24 megahertz, 24.9, it just turns the SWR light on, which is 3 to 1. So that wire has a bandwidth. We might just make a rough guesstimate of 24.9 from 21, 3 some megahertz. Ain't bad. But there to see after it's keyed down how the little bit of SWR indicator pops up. That's over about 2 wavelengths of coax, low loss LMR 400. So key point is perfectly 50.0 at the feed point. No BALUNS, no gimmicks. So, wonder how to do it? All the information you need is in my matching network videos and my antenna videos. Study them all till your eyes fall out. And then you'll know the things necessary to go do this. KBOIP.